Okay, we're going to apply the Pythagorean theorem. So our ultimate goal is to find side lengths in right triangles. So specifically, we must have right triangles. The Pythagorean theorem is that the square of the length of the hypotenuse, which is our C, is equal to the sum of the squares of the lengths of the legs. So recall that in a right triangle, the legs are the two sides that make up the right triangle, and across or opposite the right angle is the hypotenuse. So find the length of the hypotenuse. So we're always trying to find the C. So it's the square of the two sides equals the square of the hypotenuse. And then to find the number, you must take the square root. So C equals 5 root 13. And we're doing simplest radical form. So if you need to, use split or you do your prime root, prime factorization. Excuse me. Yellow calculators, if they're in the right form, will give you square roots in simplest form. Okay, we're going to find in these examples forms that are equivalent. So again, our standard form is, so just because the b squared is written first, this will still be true. If I move the a squared to the other side, this would be true. C squared is always the biggest number, so this would be false. C squared equals the sum. And if I make the b squared go over to the other side, that would be true also. Now we're going to find an unknown length. So we're going to be given this C. So remember that C squared equals A squared plus B squared. So if I want to find a leg, I can just subtract the square of one of the others. And then again, you have to take the square root. So all of these will be done the same way. These happen to all be perfect squares, so there's no need to find an equivalent or a simplified square root. Okay, we can apply this in finding the area of an isosceles triangle. So recall that the area is 1/2 the base times the height, and an altitude of an isosceles triangle is a perpendicular bisector to the base. So we'll split the base into two congruent pieces. So then we can find h from the Pythagorean theorem by subtracting the isosceles side minus 1/2 of the base. And then when you find the area, you must use that whole base, then times the height. And units squared. Okay, so first thing you gotta do when you're given the whole base, split it into two. And then take your 1/2 times that whole base times the height. Okay, I'm just going to do one more. I'm not going to do the last one. These are all done the same way. Take the square root. Then make sure you use the whole base. Then we have what's called a Pythagorean triple. It's a set of 3 positive integers. We call them A, B, and C that satisfy your equation a squared plus b squared equals c squared. So there are some common triples: 3, 4, 5, 5, 12, 13, 8, 5, 17, 7, 24, 25. And then you can have any multiples of those, and that's what it's showing you there. So we can use this to find a third side of a triangle in a Pythagorean triple. So first thing is that you can have two scenarios. You can have where your x is the hypotenuse. So if that were the case, 40 squared plus 41 squared would be a perfect square. And if you test that, that's not a perfect square. And then when x is a leg. So then if x is a leg, the longest piece up here will be the hypotenuse. And when you subtract them, you get 81. So x equal 9, and it would be a leg. So I would test it as a hypotenuse first. $13.69 is a perfect square. So this time it would be a hypotenuse. So again, test it as a hypotenuse. That's not a perfect square. Then the longest piece would be the hypotenuse minus the leg. Give me the other leg. And you take the square root of that. And you state that it's a leg. And then we have some a little bit more complex figures. I'm just going to pull out this piece up here. And I know there's a right angle there. And since all those pieces are the same, these two would be 8s. So we have 8 squared and again, it has to be in simplest radical form. So this would be 8 root 2. And again, the yellow calculators will do that. In the next one, find this piece first using the Pythagorean theorem. I'm going to leave it in squared form because I know x squared equals 14 squared minus y squared. And then simplest radical form. This is 4 times 22. So 2 root 22. And this concludes the first section with Pythagorean theorem.